Welcome to this explainer. Today we are diving headfirst into the anatomy of an API request. We're going to break down the mechanics of testing and really get into the art of decoding responses. We'll be taking a chronological journey together, starting from setting up your environment in Postman all the way to interpreting exactly what the server is yelling back at you when things go wrong or, when things actually go great. So grab your virtual lab coats because we're getting hands-on with some data today. Here's our roadmap. We're going to kick things off with setup and variable scopes, move into scripting before and after, and then tackle positive and negative testing. After that, we'll shift gears to diagnosing responses by navigating 3xx redirection codes, and finally, we'll decode those pesky 4xx client errors. All right, let's jump into Section 1, Setup and Variable Scopes. Now, before we even think about hitting send on a request, we have to know exactly where we're sending it. In real-world testing, you're almost never operating in a vacuum, right? You're dealing with multiple server contexts. This brings us to the concept of an environment, basically a specific server context like QA, staging, or pre-production. Imagine having to manually rewrite your API URLs every single time you switch from testing in QA to staging. Total nightmare. But by using environment variables in Postman, your core request structure just stays exactly the same. You literally just flip a dropdown, and your variables dynamically update the server address. It's a real game changer. But how does Postman know which variable to use? Well, it uses a very strict hierarchy. Let's say you have a variable called server address defined in all three of these places. Postman is going to check the collection variable first, and it'll use it if it finds it. If not, it moves down to the environment variable. If that happens to be empty too, it finally falls back to the global variable, which applies across all your collections and environments. Understanding this priority is absolutely crucial. You definitely don't want your tests accidentally nuking the production server when you meant to hit QA. Moving right along to Section 2, Scripting, Before and After. Okay, this is where we use JavaScript to bridge the gap between static data and dynamic logic. On the left here, we have pre-request scripts. This code runs before your API request executes, which is absolutely perfect for injecting dynamic data into your request body. On the right side, we have post-response tests. These run after the server actually replies. This is where you're going to write your automated validations, things like checking for a 200 OK status code or making sure a specific string actually showed up in the payload. So, the whole point of a pre-request script is avoiding data duplication. Think about testing a create user endpoint. If you just hard code the name John Doe in your JSON body, sure, your first test passes. But run it again, it's probably going to fail because John Doe already exists in the database. By using dynamic variables like Postman's built-in $random full name or throwing in a quick script to call the faker library, you inject a completely unique randomized name every single time you hit send. Just like that, your test becomes infinitely repeatable. Section 3, Positive and Negative Testing. Let's break some stuff. It is time to put on our mischievous tester hats. We're pivoting from the happy path to intentionally trying to break the API. A truly great QA tester thinks completely outside the box. So here's a rapid-fire checklist for you. What happens if you change the protocol from HTTPS to HTTP? Does it safely redirect or does it crash? What if you mess with a top-level domain, changing .in to .com? Try injecting an invalid query parameter, like setting page equal to ABC. Throw in some unexpected spaces, or, my personal favorite, just delete a mandatory comma right out of your JSON body. Seeing how the API handles these intentional curveballs tells you exactly how robust it really is. All right, so we've run the gamut. We've sent our perfectly crafted dynamic request, or maybe our intentionally broken negative request, out into the digital ether. The ball is now firmly in the server's court. But how do we decode what the server is yelling back at us? That brings us to Section 4, Navigating 3xx Redirection Codes. Think of the 3xx series as the server's way of politely saying, hey, I've moved, let me point you in the right direction. But the specifics really matter here. 301 means moved permanently. That old URL is gone for good. But look at 302 and 307. They both mean a temporary move. However, 302 has this quirky, kind of dangerous behavior where it might internally change your strict post request into a get request during the redirect. You definitely do not want that method changing if you're sending sensitive data. That's exactly why 307 exists. It strictly guarantees your HTTP method stays exactly the same. Post stays post. It is, for sure, the safer option. To ground this in reality, let's look at a real-world URL migration. If you try to visit the old Selenium automation website at seleniumhq.org, the server doesn't just load the page. It issues a 301 moved permanently response and automatically routes you over to their brand new home at selenium.dev. As a user, it's a seamless handoff, but under the hood, that 301 is doing all the heavy lifting. Finally, Section 5, decoding 400XX client errors. So when you get hit with a 4XX error, the server is essentially looking at you and saying, I can't process this, and honestly, it's your fault. These are the 4 most critical client-side faults you're going to encounter. 400 is a bad request, 401 is unauthorized, 403 is forbidden, and 404 is not found. Let's break down exactly what triggers each of these. We actually touched on this earlier during our negative testing segment. If you intentionally delete a comma in your JSON body, or if you just mess up the syntax of your message in general, the server looks at it and says, I have absolutely no idea what you're asking me. Boom, that triggers a 400 bad request. It brilliantly illustrates just how fragile an API request can be. You're basically speaking a language to the server, and if your grammar is off by even a single punctuation mark, the whole conversation stops. Now, the distinction between 401 and 403 trips up a lot of people. 401 unauthorized is strictly an authentication issue. It means you haven't proven who you are. Maybe you gave a bad password or forgot to include your API key. 403 forbidden, on the flip side, is an authorization issue. The server knows exactly who you are, and your credentials are completely valid, but you simply aren't allowed to view or modify that specific resource. I absolutely love this analogy from the source material. It hits the nail right on the head. A 403 forbidden is like scanning your valid employee ID card to get through the front door of your office. The building knows you work there, but when you walk up to the highly secure IT server room and scan that exact same badge, the door just flashes red. You are authenticated to be in the building, but you are not authorized to be in that room. In API terms, this is exactly what happens if you try to use your valid GitHub token to access someone else's private repository. You're getting a 403. And of course, we have the famous 404, not found. If you construct an API request pointing to an endpoint that just doesn't exist on the server, you're going to see this. It's literally like sitting down at a hotel restaurant and trying to order a dish that isn't on the menu. The waiter isn't confused by your language, and you aren't forbidden from eating. They just simply do not have the item you're asking for. And that brings us full circle. You now know how to leverage your environments, utilize pre-request scripts for dynamic data, intentionally design devious negative tests, and perfectly decode whatever response codes the server throws back at you. So I'll leave you with this thought. Is the API you are working on today truly robust, or is it just sitting there waiting for you to design the perfect negative test to break it? Go get back into your lab, start testing those edge cases, and I will see you in the next explainer.